So the series sum of AK is said to converge absolutely if the sum of absolute values converges. Absolute convergence is a stronger statement than just convergence. And it allows us to do certain things that we can't do with a series that is not absolutely convergent. Such a series, by the way, is called a conditionally convergent series for reasons that we'll see later on. Those series behave in a very strange way, and they resist attempts to manipulate them in ways that absolutely convergent series do not. Okay, so partly for that reason, most of the tests for convergence that you've learned about previously are tests for absolute convergence only. The only test that you've learned in single variable calculus that is a test for conditional convergence, not an absolute convergence test, is the alternating series test. And we'll see that later. All right, but for right now, we're going to be interested exclusively in tests for absolute convergence. The reason that we can sort of get away with that is because of the following statement, which is going to come across as inane. An absolutely convergent series is convergent. Or, stated another way, if a series is absolutely convergent, then it converges. All right? Now that statement is not quite as inane as it sounds. Because what I'm saying is that if the sum of the absolute values converges, then the sum without the absolute values must also converge. The way that we'll establish that is by saying the absolute value of the sum from k equals n plus 1 to n plus p of AK is less than or equal to the sum of the absolute values. And this is true for arbitrary complex numbers, AK. It follows from the so-called triangle inequality, which states that the absolute value, or the modulus, of the sum of any two complex numbers is less than or equal to the sum of the modulus of those numbers, the sum of the absolute values of those numbers. If this series converges, i.e. if this series is absolutely convergent, then we can make this tail less than epsilon for any given epsilon greater than 0 and any natural number p. But now, since this is less than that, this is also less than epsilon, and we would say the sum converges without the absolute values. All right, so if it's absolutely convergent, then it's convergent. And that frees us to use a test for absolute convergence, even if we're interested in a series that does not have terms that are all positive.